She had done everything right. That was the part that made it so difficult to understand. She walked every morning. She had never smoked. She cooked most of her own meals. She took her vitamins. And every single morning, for 40 years, she started her day with a large glass of orange juice, fresh squeezed when she could manage it, from a carton when she could not, because orange juice is healthy. Everyone knows that. It is on every breakfast table in America. It is what hospitals serve with morning medications. It is what every nutritional authority for the last half-century has told us is a foundation of a good diet. When her doctor told her at 67 that her blood sugar was in the pre-diabetic range, that her inflammatory markers were elevated, that her skin was aging faster than her chronological age would predict, and that her cognitive test scores had declined noticeably since her last visit, she had no idea where to look. She was not looking at the glass she put down on the counter every morning. What I am going to show you today is not that fruit juice is poison, or that you need to eliminate all sweetness from your life. What I am going to show you is the specific biochemical mechanism by which daily consumption of what most seniors consider their healthiest morning habit is accelerating 3 of the most important biological aging processes in the human body, and doing so in a way that is invisible on casual dietary analysis, that most doctors never raise in a routine appointment, and that the research on aging has now connected to outcomes that range from accelerated skin aging to cognitive decline to cardiovascular deterioration. The drink is fruit juice, and the reason it is doing what it is doing has nothing to do with the vitamins it contains. It has everything to do with what happens inside the body when concentrated fructose arrives without fiber, at speed, in the quantities that modern juice portions deliver. I am Dr. Edward. What you are about to hear is educational information based on published scientific research. It is not a substitute for personalized medical care. If you have diabetes, prediabetes, or metabolic syndrome, the information in this video is particularly relevant to your situation, and I strongly encourage you to discuss your fruit juice consumption specifically with your doctor at your next visit. Subscribe to this channel right now before we get into the science, because the mechanism I am about to explain is one of the most important things I have ever covered on this channel in terms of practical daily impact. It is free, it takes 2 seconds, and this is the kind of research that changes what you do tomorrow morning. Subscribe and stay with me. Let me start with the fundamental distinction that separates eating a piece of fruit from drinking a glass of fruit juice, because most people treat these as nutritionally equivalent, and the research shows they are not. Not slightly different, fundamentally, mechanistically different in ways that produce opposite effects on the biological processes that determine how fast you age. When you eat an orange, the fructose it contains, approximately 12 grams, arrives in your digestive system embedded in a matrix of soluble and insoluble fiber, cell walls, and pectin. That fiber does several things simultaneously. It slows gastric emptying, the rate at which the stomach releases its contents into the small intestine. It forms a viscous gel in the gut that slows the absorption of sugars across the intestinal wall. It feeds the gut microbiome, producing short-chain fatty acids that improve insulin sensitivity in the liver. And it provides a satiety signal that regulates how much you eat overall. The fructose from a whole orange enters the bloodstream slowly, over 90 minutes to 2 hours, at a rate the liver can process without stress. When you drink a glass of orange juice, the fiber has been removed. The fructose, now approximately 21 to 25 grams in a standard 8-ounce glass, the equivalent of eating 2 full oranges, arrives in the small intestine within minutes. There is no gel to slow absorption. There is no fiber to regulate the rate. The fructose passes through the intestinal wall rapidly and arrives at the liver in a concentrated bolus. The liver, which is the primary organ responsible for fructose metabolism, is not designed for this. It cannot process a large fructose load rapidly. What it does instead is convert the excess fructose it cannot immediately metabolize into fat, a process called de novo lipogenesis. Some of that fat stays in the liver, contributing to hepatic steatosis. Some of it is packaged into VLDL particles and released into the bloodstream as triglycerides, and the remainder undergoes a metabolic pathway that produces uric acid as a byproduct, a compound whose effects on aging I am going to explain in detail. This entire cascade begins within 20 minutes of drinking the juice, not after months of consumption, within 20 minutes of a single glass. Now let me explain why this matters for aging specifically, because most people understand that sugar is not ideal for blood sugar management, but very few understand the 3 specific aging mechanisms that the fructose cascade I described activates, mechanisms that are producing visible and measurable biological aging in people who believe they are being healthy. The first mechanism is advanced glycation end products, AGEs. This is a term you may have heard in anti-aging contexts, and I want to give you the precise biochemistry rather than the vague headline. Glycation is the non-enzymatic reaction between sugar molecules and proteins or lipids. When sugars, particularly fructose, which glycates proteins at a rate approximately 10 times faster than glucose, are present in high concentrations in the blood and tissues, they bind to the proteins that make up your body's structural and functional tissues, collagen in the skin and arteries, proteins in the lens of the eye, myelin in nerve fibers, hemoglobin in red blood cells. The fructose molecule attaches to these proteins, alters their structure, and eventually cross-links adjacent protein molecules into rigid, dysfunctional complexes, the advanced glycation end products. Once formed, AGEs are essentially permanent. The body has no efficient mechanism for breaking them down. In the skin, age formation in collagen produces the cross-linking of collagen fibers that makes skin stiff, less resilient, and prone to the deep creasing and loss of elasticity that is the hallmark of accelerated skin aging. The yellowing and dulling of skin tone in older adults is partly the result of age pigmentation. The Maillard reaction products formed when glycated proteins oxidize. In the arteries, age formation stiffens the arterial wall, reduces its ability to dilate in response to blood flow demands, and contributes to the arterial stiffness that drives systolic blood pressure elevation in seniors. In the lens of the eye, age formation in lens proteins is the primary mechanism of cataract formation, the opacification of the lens that is the leading cause of vision impairment in adults over 65. A study published in the journal Diabetologia found that fructose consumption was independently associated with elevated plasma age levels in non-diabetic adults, meaning you do not need a diabetes diagnosis for this mechanism to be running. Subscribe to this channel right now if the connection between what you drink every morning and how your face, your arteries, and your eyes are aging is landing for you. This is exactly the research I translate every single week. Subscribe. It is free, and I will make sure the follow-up content reaches you directly. The second mechanism is uric acid elevation and its downstream inflammatory consequences. I mentioned that one of the byproducts of hepatic fructose metabolism is uric acid. This is not incidental. It is a specific and documented consequence of the fructose metabolic pathway that does not occur with glucose metabolism. When fructose enters liver cells, it is phosphorylated by an enzyme called fructokinase in a reaction that consumes ATP, cellular energy, without the regulatory feedback that controls glucose phosphorylation. This means fructose metabolism in the liver can proceed in an unregulated manner, depleting cellular ATP and producing AMP as a byproduct. AMP is degraded to uric acid through the purine degradation pathway. The result is that every time a large fructose load hits the liver, uric acid production spikes. Why does this matter for aging? Because uric acid, at the elevated levels produced by regular fructose consumption, has 3 specific aging-relevant effects. First, it is a potent inhibitor of nitric oxide synthase, the enzyme that produces nitric oxide, the molecule that keeps blood vessels flexible, responsive, and protected from atherosclerotic plaque formation. When uric acid is chronically elevated, nitric oxide production falls, endothelial function deteriorates, blood pressure rises, cardiovascular aging accelerates. Second, elevated uric acid directly activates the NLRP3 inflammasome, one of the primary drivers of the chronic low-grade inflammation that gerontologists call inflammaging, the age-related inflammatory state that underlies cardiovascular disease, cognitive decline, sarcopenia, and most age-related diseases. Third, elevated uric acid crystallizes in joints and soft tissues, producing the gout that affects an estimated 9 million Americans, but also producing subclinical joint and tissue inflammation that does not present as gout, but that contributes to the stiffness, reduced mobility, and joint pain that seniors commonly attribute simply to age. A study published in the Journal of the American Medical Association examined the relationship between habitual fruit juice consumption and serum uric acid levels in adults without a prior gout diagnosis. Regular fruit juice consumption, defined as 1 or more glasses per day, was independently associated with a 45% higher risk of developing gout compared to non-consumers after adjusting for all other dietary and metabolic factors. The mechanism was confirmed as fructose-mediated uric acid overproduction rather than any other component of the juice. The third mechanism is the NAD+ depletion that I described in my previous video on cellular aging. I want to revisit it here because it has a specific and direct connection to fructose metabolism that I did not fully develop in that video. NAD+, nicotinamide adenine dinucleotide, is the substrate required by the sirtuin longevity proteins to perform DNA repair, mitochondrial regeneration, and cellular maintenance. NAD+ falls by approximately 50% between age 40 and 60, and this fall is one of the most robust correlates of accelerated biological aging in the cellular biology literature. What I want to add to that picture now is that the ATP depletion produced by unregulated fructokinase activity in the liver, the same pathway that produces uric acid, also activates PARP1, the emergency DNA repair enzyme I described in the cellular aging video. PARP1 activation consumes NAD+ at an extraordinary rate. Every episode of significant fructose loading produces a PARP1 activation event in liver cells that draws down the NAD+ pool. A person drinking a glass of fruit juice every morning is creating a daily NAD+ depletion event in their liver, the organ with the highest metabolic NAD+ requirement in the body, before the day has even begun. The sirtuin system that depends on that NAD+ to run cellular repair is being starved of its substrate by the drink that was supposed to be delivering vitamins. Research published in Nature Metabolism examined liver NAD+ concentrations in subjects consuming diets with varying fructose content. High fructose intake was associated with significantly reduced hepatic NAD+ and reduced SIRT1 activity in liver tissue. The authors concluded that fructose-mediated NAD+ depletion represented a previously underappreciated mechanism connecting dietary fructose consumption to accelerated hepatic and systemic aging. The connection between what you drink every morning and the fuel available for your cell's maintenance programs is not theoretical. It is measured, published, and replicated. Now I want to share something with someone right now. Someone in your life who pours a glass of juice every morning and considers it one of the healthy things they do. You now understand 3 specific molecular reasons why that glass may be working against them more than for them. Share this video with them before it ends. And if you are not already subscribed, tap that button right now, because the nutritional research I cover every week changes the way people understand what they are actually putting in their bodies. I want to now address something that I suspect is the objection forming in the mind of most people watching this. But orange juice has vitamin C and potassium and folate and antioxidants. Is the vitamin C not worth it? This is a completely reasonable question, and I want to answer it with precision rather than dismissal. Yes, orange juice contains vitamin C, approximately 70 milligrams in an 8-ounce glass, which is close to the recommended daily intake. It also contains folate, potassium, and hesperidin, a flavonoid with documented anti-inflammatory properties. These are real nutrients with real benefits, and I am not going to minimize them. But here is the calculation that most people never perform. The vitamin C in 1 glass of orange juice is available in a handful of strawberries, a third of a medium bell pepper, or a half cup of broccoli, none of which deliver 21 grams of fructose, none of which produce the glycation cascade, the uric acid spike, or the NAD+ depletion I described. The potassium in orange juice is available in half a banana or a small sweet potato. The folate is available in a quarter cup of lentils. The nutrients that juice delivers have entirely adequate alternative sources in whole foods that do not carry the aging-accelerating fructose load. You are not choosing between vitamin C and aging faster. You are choosing between getting your vitamin C from juice or getting it from a source that does not come with the fructose penalty. This is not a fringe position in nutrition science. A study published in the British Medical Journal following over 187,000 adults for more than 20 years found that whole fruit consumption was associated with reduced risk of type 2 diabetes, while fruit juice consumption was associated with increased risk, using the same fruit, the same vitamins, the same antioxidants. The difference was the removal of fiber and the resulting change in the fructose absorption kinetics. The nutrients are not the variable. The delivery mechanism is. Now let me talk about the other drinks in this category, because orange juice is the most prominent, but it is not the only daily beverage most seniors consume that falls into this pattern. Apple juice is actually worse than orange juice from a fructose perspective. Apple juice contains more total sugar per serving than orange juice and a higher proportion of fructose relative to glucose, with fructose accounting for approximately 60% of the total sugar content. The glycation rate, the uric acid production, and the NAD+ depletion from daily apple juice consumption are all greater than from orange juice. Apple juice also lacks the hesperidin and some of the flavonoid content that partially offsets some of the inflammatory burden of orange juice. It is marketed to seniors as a gentle, digestive-friendly choice. The research does not support that characterization. Grape juice sits at the other end of the spectrum within the juice category. It has the highest resveratrol content of any common juice, which has genuine cellular protective properties, but also the highest total sugar and caloric density. Purple grape juice at small quantities, 2 to 4 ounces, may represent a genuine trade-off worth considering for its polyphenol content. A full 8-ounce glass daily eliminates that trade-off. Cranberry juice cocktail, which is what most cranberry juice products sold in supermarkets actually are, is not a juice at all in any meaningful nutritional sense. It is primarily added sugar or high fructose corn syrup with a small amount of actual cranberry juice added for flavor and marketing. The urinary health benefits attributed to cranberries come from a compound called proanthocyanidin A that is found in the whole berry and in high concentration cranberry capsules, not in the amounts present in a glass of cocktail at the sugar to cranberry ratio that commercial products use. The person drinking cranberry juice cocktail daily for urinary tract health is getting negligible proanthocyanidin and substantial fructose. Smoothies deserve their own consideration because they occupy a different position than juice. A smoothie that contains the whole fruit, including the fiber, the skin where relevant, and the cell wall material, is not nutritionally equivalent to juice and does not produce the same fructose absorption kinetics. A smoothie blended from whole fruit retains fiber that, while mechanically disrupted from its original structure, still slows gastric emptying and moderates the blood sugar response compared to juice. However, and this is important, a smoothie that contains more than 1 to 2 servings of high fructose fruit, particularly mango, pineapple, banana in large quantity, and grapes, produces a significant fructose load even with the fiber present because the blending process pre-ruptures cell walls and begins the process of liberating sugars that would otherwise require chewing and digestion to access. A smoothie is not juice, but a large smoothie is not a vegetable either. Subscribe to this channel right now if you want the complete guide to what seniors should be drinking for genuine cellular protection, the specific beverages, the specific compounds, and the specific amounts that the research supports. That video is coming, and you will want to see it. Subscribe so it finds you directly. Let me now give you the practical framework for what to do with this information, because I want this to be immediately actionable rather than simply alarming. If you currently drink fruit juice daily and you want to preserve the morning ritual while eliminating the fructose penalty, the most evidence-supported replacement is water with a small amount of whole citrus, slices of lemon, orange or grapefruit that add flavor, some hesperidin, and minimal fructose without the concentrated sugar load of a glass of juice. Green tea in the morning provides catechins that directly activate AMPK, the cellular energy sensor I described in the previous video. and has a specific evidence base for reducing glycation, reducing uric acid, and supporting NAD+ availability. Hibiscus tea has among the highest anthocyanin content of any beverage and has been shown in randomized controlled trials to reduce both systolic blood pressure and uric acid levels. If you want to retain some fruit juice in your diet and are not willing to eliminate it entirely, the evidence supports limiting it to 2 to 4 ounces per day rather than 8, drinking it with a meal that contains fiber and protein rather than as a standalone first thing in the morning on an empty stomach, and choosing whole fruit as the primary vehicle for fruit-derived nutrients with the juice serving as an occasional flavoring rather than a daily staple. The morning timing is particularly important. Drinking juice first thing in the morning on an overnight fasted stomach with no other food present produces the maximum possible glycation and uric acid response because there is no food matrix, no competing fiber, no protein to slow absorption, and the liver is in its most glycogen-depleted state when it receives the fructose load. If juice is consumed at all, consuming it partway through a meal that includes eggs, whole grains, or other protein and fiber sources meaningfully blunts the fructose absorption curve. Here is the summary of everything we covered. Fruit juice and whole fruit are not nutritionally equivalent despite containing the same vitamins, because the removal of fiber changes the fructose absorption kinetics from slow and regulated to rapid and concentrated. A standard glass of orange juice delivers 21 to 25 grams of fructose in minutes rather than hours, producing 3 specific aging-accelerating mechanisms: advanced glycation and product formation from fructose's 10 times faster glycation rate compared to glucose, producing irreversible cross-linking of collagen in skin and arteries, lens proteins in the eye, and structural proteins throughout the body, elevated uric acid from hepatic fructose metabolism, inhibiting nitric oxide production, activating the NLRP3 inflammasome, and driving the chronic low-grade inflammation that underlies most age-related disease, and NAD+ depletion through PARP1 activation, starving the sirtuin longevity system of its substrate and suppressing the cellular maintenance programs that depend on adequate NAD+ to run. The nutrients in fruit juice are available from whole food sources that do not carry the fructose penalty. The British Medical Journal cohort study showed that whole fruit consumption reduces diabetes risk, while fruit juice consumption increases it using the same fruit. Practical interventions include replacing morning juice with water with citrus, green tea, or hibiscus tea, limiting any juice to 2 to 4 ounces with a fiber and protein meal rather than alone on an empty stomach, and using whole fruit rather than juice as the primary vehicle for fruit-derived nutrition. Please share this video. The morning glass of juice is one of the most deeply entrenched beliefs in senior health culture, and it is one of the hardest to dislodge because it has 40 years of institutional endorsement behind it. The person in your life who starts every morning with a large glass of juice and takes it as evidence of their healthy habits deserves this research. Share it with them, not to take something away from them, but to give them a choice they currently do not know they have. Subscribe to this channel if you have not already. My next video covers the complete morning beverage protocol for seniors, the specific drinks with the strongest evidence for activating AMPK, supporting NAD+, reducing glycation, and protecting the cardiovascular and cognitive systems against the biological aging mechanisms I described today. Subscribe so it comes directly to you. I am Dr. Edward. What you drink every morning is either working for your cells or against them. Now you know the difference. I will see you in the next one.